Okay, everybody, we're reviewing geometry today. Remember that we have learned already how to identify points, lines, line segments, rays, angles, and perpendicular and parallel lines. We know how to identify and draw one or more lines of symmetry, if they exist, on a two-dimensional figure. We know how to apply our knowledge of right angles to identify acute right and obtuse triangles. And today our focus, classify two-dimensional figures based on presence or absence of parallel or perpendicular lines or the absence of angles of a specified size. So let's take a look at this question, which says a figure is shown below which two line segments appear to be perpendicular. Now remember, perpendicular means it has right angles when they intersect. Okay, so which ones of these look like they might have perpendicular lines if they cross over? So let's say if, letter F, AG and CD, are those ever going to intersect? AG and CD are parallel to each other. They're not going to intersect, so they're not going to be perpendicular lines. What about letter G? Line segments BC, okay, BC, and CD. Yes, okay, so if those line segments were to continue, they're going to cross over each other and form 90-degree angles. So the answer is G. If you look at the other answer choices, like let's look at H, it says DE and EF. Those intersect, but it forms a V. Those are intersecting lines, not perpendicular. Perpendicular lines are 90-degree angles when they cross over. And J, AG, AG, and FG, same thing. You see when they cross over, when they intersect, they form V's. And we're looking for squares or right angles. So our answer is G. In this example, they're asking us about lines of symmetry. Which figure appears to have exactly one line of symmetry? Which one has one line of symmetry? So if I fold this figure in half, that will match up, but if I fold it in half this way, it's also going to match up, so that's two lines of symmetry there. All right, what about C? I don't see any symmetry here, actually. No, that has 0 lines of symmetry. All right, what about B? I can fold it down the half, and it will match up this way. If I fold it this way, no, it's not going to. So that has one line of symmetry. This is our answer, letter B. And D has more than one line of symmetry, doesn't it? It has 1, 2, 3. It has like 4 lines of symmetry. All right, so our answer, B. Good job. One line of symmetry, exactly. Okay, which triangle appears to be an acute triangle? An acute triangle, well, we're looking for angles that are less than 90 degrees, smaller than a right angle. Letter F has an obtuse angle right here that's larger than a square corner, right? So it's not F. G, yes, G is our answer. Those are all less than 90-degree angles, so that makes it an acute triangle. H is what type of triangle? Correct, it's a right triangle. That's a perfect square corner there. And then J is an obtuse triangle. Remember, we name our triangles based off of the largest angle, and this one has an obtuse angle and 2 acute angles. So nope, we are correct with our answer choice G. All right, so here's our focus today, 4.6D. Which figure cannot have parallel line segments? Well, a square has parallel line segments, doesn't it? It has 4 or 2 sets, 2 pair of parallel lines. A pentagon, okay? A pentagon does have a set of parallel lines, doesn't it? It has 5 sides. Triangle. Ooh, well, a triangle, you cannot have parallel line segments, can you? Everything is intersecting on all 3 sides. All 3 of those angles intersect. Okay, so C, it does not have parallel line segments. Does a trapezoid? Yes, a trapezoid has 1 set of parallel lines. So our answer is C. Let's look at number 14. Lisa drew a picture on the front of her notebook that has 2 obtuse angles. Which figure could be the one Lisa drew? Oh, okay. So she drew a figure with 2 obtuse angles. Well, we know that rectangles have 4 right angles, so it's not F. G, obtuse triangle. An obtuse triangle is going to have 1 obtuse angle and 2 acute angles. No, this one needs 2 obtuse angles, so it's not G. Okay, what about a parallelogram? Yes, a parallelogram does have 2 obtuse angles and 2 acute angles. So our answer is H. Obviously, it's not a right triangle because a right triangle has 1 right angle and 2 acute angles. So our letter H is correct. All right, last one. 4 figures are shown below. Which figures appear to be rectangles? Which ones appear to be rectangles? Well, remember, rectangles have 4 sides. They have 2 pair parallel line segments, and they have 4 right angles. 4 right angles. So which 2 are rectangles? Right, figure P is obviously a rectangle, and figure R is a square, which is a special type of rectangle. So what's wrong with Q? Does not have right angles, correct? Same problem with figure S. There's a pair of obtuse angles and a pair of acute angles. Q and S are not rectangles. So our answer is letter C. Figures P and R appear to be rectangles. Okay, you guys are ready. Good job.